Hello. This time I want to talk about numbering systems. Okay. What is a numbering system? Well, a numbering system is something we can count with. Yeah. I guess all of you have heard about our usually used decimal system. The decimal system, what is it? Yeah, decimal system consists of 10 different signs, let's call them. Yeah, we call them digits. So we have 10 different digits. We have the digit 0, we have the different digit 1, we have the digit 2, 3, 4, 5, 6, 7, 8 and 9. Okay, that's our pool of symbols. The decimal system consists of 10 symbols. Okay, and every time I want to count one more, I increase the symbol. Okay. So let's say I do have a 5-digit number. Yeah? I'll make it a little bit smaller. Let's say I have a number. Yeah? If I have nothing, it looks like this. Okay? Put it in the middle. If you have nothing, it looks like this. Then I want to count one more. Then I want to count one more. Second, third symbol. I want to count one more, and 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 one more. Now I am at the 10th symbol. We call it 9. Yeah? That's the symbol with the name 9. That's the 10th symbol of the decimal system. And now, what happens now? If I count one more, I cannot use another symbol. Yeah? My symbol pool is empty. Yeah? So I'm using the next place. Yeah? I say, okay, one time I've used all symbols, and I start again with the first symbol, our 0. And then one more, 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 one more. I'm already at the end. So now here, one more time, I've used all symbols on the previous digit. Okay. This is how a numbering system is working. So we do have here our digit numbers. 0, here we have the digit number 1, we have the digit number 2, we have the digit number 3, we have the digit number 4, and so on. Yeah? I'll add here some 4. That are the places. Yeah? Above here we have the value. And if I have this value, yeah, it's 1250. One time I've used all possible combinations of these 3 digits. 2 times, plus 2 times, I've used all possible combinations of these 2 things. Plus 5 times, I've used all possible combinations of this. Sounds now a little bit confusing. A little bit confusing. But we will see what I mean if we get there. So how much worth is one digit at this position? 1. Every time I count here 1 up, it's 1 more. Okay. How much worth is a count at this position? Yeah? It's 10. Every time I count here, I have 10 more. How much worth is a digit at this position? It's 100. Ooh. And guess what? Here it's 1000. Yeah? And here it's 10,000. Every time times 10. That's how much is a ticket at this position worth. Or to write it in a more mathematical way, yeah? I could also write here we have 10 by the power of 0. That's 1. Here we have 10 by the power of 1. That's 10. Here I have 10 by the power of 2. That's 100. Here I have 10 by the power of 3. That's 1000. Here I have 10 by the power of 4. That's 10,000. And so on, and so on, and so on. Okay. And here you can see how these corresponding numbers of the digits are corresponding to the value of the digit, of one digit. Yeah? Every time 10 raised by the power of whatever position. 0, 0, 1, 1, 3, 3. Okay? Easy. Huh? And basically what we do here, yeah, in our head, with no issue at all, we say this here is 1 multiplied by I'll make it a little bit bigger again that we can see. Of course. Okay. 1 time, because it's 1 here, 1 time 10 by the power of 3. Then 2 times 10 by the power of 2. Then 5 times 10 by the power of 1. And 0 times 10 by the power of 0. Yeah? And therefore now calculate this. So we have 1000 here. Here we have 200. 2 times 100 is 200. Here we have 50 and we have 0. And if I add everything, 1000 plus 200 plus 50 is 1250. Wow. Okay. This is how a numbering system is working. We have a reservoir, a pool of symbols. Yeah? We take all the symbols, and if we are done at one position with all the symbols, we start the next position. Yeah? The next position is then worth the number of symbols I have multiplied by the number of symbols I have. That's it. Okay, so that's the decimal system. There are systems which are there for almost every count of symbols. Yeah, one very famous system is the binary system. Binary system. The binary system has only a reservoir, a pool of two numbers, of two symbols. Yeah. Now I'll just copy this. So for instance, I have this. This is my number. Yeah. This is position 0, 1, 2, 3, 4, and so on. And here, I will delete this now. And here, it's not 10 raised by the power, it's 2. Yeah? Because we do not count 10 symbols, we only count 2 symbols. So if we count here 1, this symbol has already reached 2. So this is worth 2. This is worth 4, this is worth 8, and so on. So every times 2 by the power of the position. Okay? So this means this is 1, 2, this is 2, this is 4, this is 8, this is 16, and so on. Okay? And here we do it the same. That's of course then 2, 2, 2, 2, 2. 1 time this, 0 times this, 1 time this, 1 time this. 1, 0, 1, 1, 1, 0, 1, 1, and here the values. 1 time 8 is 8. 0 times 4 is 0. 2 times 1 is 2. 1 time 1 is 1. And if I now add everything together, 8 plus 0 is 8, plus 2 is 10, plus 1 is 11. This number is 11 in decimal. Okay? But you see, it's working exactly the same. Yeah? It's the decimal system, it's the binary system. Here we have 10 digits. Here we have 2 symbols, 10 symbols, 2 symbols. Here we have each next step is worth the symbol count multiplied by the position, yeah, raised by the power of the position. Yeah. How would this look like here? Yeah. At the beginning I have nothing. Yeah. Then I have 1. Plus 1 is 1. Then I'm done. I'm done with this digit. Yeah. So I start the next position. And then here. Yeah. Here I'm done with this digit. I have to go here. Book, book. And plus 1. Plus 1. Plus 1. Plus 1. Plus 1. Plus 1, plus 1. Okay? This works exactly the same. Yeah? But why is a binary system, why is that so famous? Why is that so important? Because computers usually work with the binary systems. You know? Computers are working in our digital world, digital, just 2 positions, 0 or 1, hey, yeah. And everything else is just a combination of 0 and 1s. Yeah. Why is this? Because a computer is working with there is current, or there is voltage, or there is no voltage. There is not half voltage in a computer. It's always 0 or 1, and it's working with it. This is why binary system is that important in our world. Yeah. Binary system. Usually you group such binary numbers. Yeah. A usual grouping is eight bits, 8 digits. In binary they are called bits, 8 bits, and this thing is called a byte. Yeah. Why is a byte exactly 8 long? How many different numbers you could write with an 8-bit binary number? It's not that easy to answer. How many digits or how many combinations we could write with a 2-digit decimal system? Yeah? We could write maximum number is 99. Yeah? And plus 0, 100. So with a 2-digit we can exactly have this amount of different combinations. With the 3 digits the maximum number is 999. Yeah? Plus 0 is 1000. That's the maximum number for a 3-digit decimal number, and that's the maximum number. That's the maximum number for a 4-digit binary decimal number. Yeah? So remembering what is the maximum number of an 8-bit binary number, it's of course 2 raised by the power of 8. Yeah? And that's 256. Yeah? 1, 2, 4, 8, 16, 32, 64, 128, 256. 256 different combinations I could have with 8 digits. So why is it just 8? Yeah, or exactly 8? Why? Because the background was that they wanted to write something. Yeah, so they needed one symbol for each letter. Yeah, and so there are capital letters, there are small letters. So we have 26 capital letters, we have 26 small letters. Then we want to write 0 to 9, the numbers, so plus 10. Yeah. Then we have a bunch of special characters like plus, minus, semicolon, dot, comma, percent signs, dollar signs, whatever. So add a number for these. Yeah. Then we would have control information or non-printable characters like a return, a line feed, or a carriage return, a backspace. We would need some number for positioning the cursor left, cursor right, cursor down. We would need something for control, for tab, and so on. And then they came up, we need around 256. 256 should be enough for representing almost every text message in our alphabet. Yeah, because in different alphabets we maybe use additionally. In Austrian or in German we have Ö, Ü, yeah, special. Then in Scandinavia they have this Ö with this striked O sign of letter, and so on. So they added and they came up with, I don't know, 180, and they added then some strange things like border things and so on, and said, okay, 256 should be enough. So we need 8 bytes. 8 bytes should be sufficient to represent all text. Okay, and so we call this 8 bits, we call one sign, one character. One character, and this is a byte. And this is why a byte is a byte, 8-bit. Okay, and this is why a byte can hold 256 different values. With 1 byte you could count from 0 to 255. So 256 different variations. Okay, that's 1 byte. Yeah, half of a byte, so only 4 bit, they are called a nibble. Yeah, that has nothing to do with some gate. Yeah, this nibble has no gate, it's called a nibble, a little bit, nibble. Yeah. Nibble. Yeah. And then there is 2 bytes, so if we have 16, that's a so-called word. What's up, word? Word. Okay, and a double word would then be 32-bit. That's about the naming. So, binary system, why is a byte a byte? There's one pretty useful numbering scheme is left. That's the hexadecimal system. Yeah? And hexadecimal, hexa is 6, decimal is 10, 16 different signs, and those signs is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we ran out of digits as we know it, so we use just the letters. Start with A, B, C, D, E, F. 16 different symbols. 16 different symbols. I will copy this table again. Clackety clack. Here we have 16 by the power of whatever. Ooh. Something happens. 16. Position 0, 1, 2, that's the same. We have 1. Here we have 16. Here 16 squared. What is this? 16 multiplied by 16. Let's call the calculator. 16, 256. What is this? Multiplied by 16. 4096 multiplied by 16. 65,536. That's the value. If we start counting, we start with 0. Plus 1, 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 plus 1. Now we are not done. Plus 1, plus 1, plus 1, plus 1, plus 1, plus 1. Now we're done. Okay? And suddenly plus 1. It's working. Yeah? Exactly the same as the decimal system. Now here this means now we have 16, the value of 16. Yeah? So let's say we have here 1 A D 4. Bah! Score. So we have 1 time 16 by the power of 3. Yeah? We have A is 10. 10 times 60 by the power of 2 d. B is 11, 10, 11, 12, 13, 13, 16 by the power of 1, and with 4 times. Yeah. So we have 1 time, that's 4096. We have 10 times 256, so this is 2560. 2000, hello, 2560. We have 13 times 16, yeah, pooh, I will type this in, 208. And we have 4 times 1, that's 4, that's easy. Yeah? And so we do have in total 4096 plus 2560 plus 208 plus 4, 6868. 6868. What? Really? Yeah. Okay. 6868. This would be 184 in decimal. Okay. Hexadecimal system works exactly like every other numbering scheme. So why is this famous? Why is it used? Yeah? The reason is because it's very, very close to the binary system. With 4 digits, yeah, you can 2 raised by the power of 4 have different combinations, 16 combinations. Yeah. And this one has 16 different symbols. So you can write every 4-bit, every nibble with 1 hexadecimal number. Yeah. And this is making the reading very, very easy. Yeah. So like said, this here 1011 is 11 and 11 is B. So this would be hexadecimal B. Okay. And so I can take every 4-bit, translate them or put them into the hexadecimal system very easily. And then I don't, for instance, I write now a decimal number, yeah, I'll write them together. Okay. Now, yeah, read it. Puh. Yeah, or write it down, copy it, yeah, write it on a letter. You make for sure a mistake. But if you group them into chunks of 4, 4 positions, you can simply translate them into a hexadecimal system. So 1, let's start here, yeah, the last one, which is this 1, no 2, but 4, so this is 5. This would be 5. Yeah. 5. This is a 5. What's this? This is 1 and 2, so it's 3, and 8 is 11. 11 is a B. What do we have here? 1 and 4 is 5, and 8 is 13. So we have a C here. And what is this? 8 and 1 is 9. Yeah. So that's the hexadecimal representation, 9CP5. And now you can easily write it down. Huh? No issue. Much less letters. And every two hexadecimal letters is exactly 1 byte. That's used very often. Yeah. So this is 2 byte number, first byte, second byte, and this nibble is a 5, this nibble is a B, this nibble is a C, this nibble is a 9. Okay? So this is why a hexadecimal system is used very often. However, we have to take care to mark those things. Yeah? So if, for instance, I write this, we would interpret it as 102. Why not? It's 102 for us. However, what if I meant it, this should be in hexadecimal number? So it's 102 in hexadecimal. Yeah? I usually write it like this. Yeah? Sound it's clear. Yeah? Hex. It's a hexadecimal number. Yeah? Or you can even mark it with this. It's a decimal number. Okay? Or this one. What is this? Is this decimal? Is this hex? Is this binary even? If you write it next to it, it's clear. It's a binary number. Yeah. Unfortunately, most of our interpreters, most of our coding and so on, they do not allow to write something as index or something like this. So usually there are special signs or special syntax. For instance, a lot of would interpret this as hexadecimal. Yeah? Or maybe this is also very often. There is no real standard for this. You have to look into the coding. Yeah? What your program language or wherever you write this needs, you have to sign it somehow. Important thing is that you can distinguish between decimal, hexadecimal number. Yeah. In my script, I'm using this. Yeah. This marking. Okay, so that's about it for numbering system. There are different codes still. I will make a second video, but that's it for numbering systems. Short introduction. To help you understand, all those numbering systems are very, very much the same. Okay, just the only real difference is the count of the different symbols, the symbol reservoirs. That's it. They work every time the same. Binary system is famous or is more used because it's used in computers. Computer work with it. And the hexadecimal system is very famous because it's very close to the binary system, because every nibble, every 4-bit is translated into 1 digit of the hexadecimal number. And is then easily readable by by humans. The computer has no issue with this long string of zeros and ones. Yeah. Okay. I hope this helped a little bit understand numbering systems. Thank you very much for your attention. Have a good day.